Hello everyone, my name is Neeraj Gulati. I'm a student at LJMU and currently pursuing Masters in Machine Learning and Artificial Intelligence. My student ID is 939914. Today I'll be presenting my final thesis. Topic of my thesis is prediction of Airbnb prices using NLP and machine learning. My thesis supervisor name is Ankit Bhatia. Airbnb is an online marketplace for lodging services. They opened up their business in 2008 and have been growing exponentially since then. Today, they have got about 5.6 million active listings in about 220 countries, so they have got a worldwide presence. In hospitality industry, Airbnb is one of the biggest competitors. The benefits of Airbnb is hosts can earn revenue from their spare rooms, which is the spare space that they have available and that can be offered to customers, and for that they get the rental income. And also it allows customers to access these properties at cheaper prices compared to traditional hotel rooms. What we can observe is that price is the key factor here, because if the host set up the prices too high, they may not be able to get enough customers to break even, and if they set it too low, then it might not be a profitable proposition for them. So defining the right price is quite critical. So the problem these hosts face day to day is that what should be the right price for the offered room. Also, because these owners do not have any technical background, they have a very limited knowledge of pulling these data points together and analyze and also understand any pricing strategies that competitors may be following. And also, with recent impact of COVID-19 on Airbnb, which not only impacted its business but hospitality industry worldwide, and it has made it very challenging because many people who booked their holidays have cancelled it, and also now when they are booking it, they want to ensure that all the COVID safe guidelines are being followed. So these days it's more relevant for hospitality industry that we do this analysis and determine the right prices for the Airbnb rooms. The main aims of our thesis was to develop a generalized machine learning price prediction model, also investigate impact of pandemic COVID-19 on Airbnb. We also wanted to utilize the customer reviews data and also built a prototype of an industry-ready price prediction tool. Before we started off with any analysis, we wanted to perform some literature review. So there were many researches that were done around Airbnb, the most relevant to our topic, which is price prediction. And the recent researches that we found were done in the geographies of New York and Melbourne. So in these geographies, a couple of researchers performed extensive analysis and tried to build a price prediction model using the data sets that were available to them. They explored range of algorithms from simple linear regression to bagging and boosting models, and also a few tried the advanced neural networks as well. We also studied some other researches to get an idea how a regression problem may be solved. During the literature review, what we identified was that there were few gaps that were identified in the literature review. In some of the researches, the dataset that was used was not quite big, so they were either datasets based on 1 month of active listings, so which did not allow any chance for the model to learn about any seasonality, or the datasets that were used had very less number of features. In some of the studies where reviews data was used, those studies did not utilize the reviews in non-English language. Also, where deep neural networks were used, the networks were not tuned enough to get them a better outcome. Also, no attempt was made to provide a front end that would enable hosts to consume these models. So all these models were just built and left as it is. There was no way for the host to deploy these models and make make them available for their use. So we set up our research methodology. So first of all, we defined the scope and the data that we are going to use. So for our research, we chose New York as our geography, and we pulled together data for 12 months, which is January 20 to December 20. This allowed us to have full 12 months, which may be including seasonality factor as well, and also it gave us a good overlap of pre and post COVID timeframes. We performed detailed analysis and feature engineering on these datasets. The main NLP component in our research was on the customer reviews data, where we performed some sentiment scoring. The algorithms that we used to build the regression models were linear regression, XGBoost, random forest, and deep neural networks. And the models were evaluated on R square, mean absolute error, root mean square error, and mean square error. These evaluation metrics are same as what the other researchers used in their studies, and the reason was that it would give us a good comparative metric and understand if our modeling approach gave us any better results. And we also tried to develop a prototype. The prototype was built on HTML, and then Flask web framework was linked to the front end. An API call will be made to reflect the predicted prices. In our research methodology, first we picked up the listing datasets and analyzed we cleansed the dataset for it to be usable for the models. So first and foremost, we tried to ensure that all the data sets that we pulled for individual months from January 20 to December 20, they had consistent variables. We removed any variables which may be redundant because they were unique, like date format or any ID type variables. So we removed all of them, and also any rows or columns that had very high null values. We also performed a correlation analysis to understand if there are some highly correlated variables which can be removed. Also, for the data which was missing, we tried various imputation techniques like mean imputation or mode imputation and tried to complete the data which would be apt for the modeling. And the last step was to convert some of the categorical variables into numeric by using one-hot encoding. The other part of the data was the customer reviews data. So through our initial analysis, we learned that about 12% of the customer reviews were in non-English language. So these reviews came in from the customers who traveled to New York from abroad, let's say France or Spain, and after their stay, they provided the reviews in their native language. In all the historical or previous researches that were done, so these reviews were completely ignored. So we thought that 12% is quite a significant number and we should not be ignoring that. So why not try and utilize this data as well and see what outcome it throws back to us. So we utilized a library called Google Trans and converted all these non-English reviews into English language and utilized the Wader algorithm and got some sentiment scores out of it. So that was one of the main features in our dataset. After that, we also looked at adding some more features to the data. So another critical feature that we added was distance from the city center. Distance from the city center is also quite relevant when customers are booking the properties for holiday because they would like to be closer to the tourist attractions. And also we created some features from our amenities column. In amenities column, all the amenities that were offered by the property were clubbed together. So we had to separate them out individually through some data manipulation and processing. So after doing all this feature engineering, our data set was worth 750 variables. So this was quite huge. We knew that we cannot directly implement this we cannot use these 750 variables and create some models out of it, because majority of these variables may be zero for many of the observations. So we had to perform some kind of dimensionality reduction technique on this data. Also, we looked at our target variable price to understand if there were any outliers. So first we did a box plot by month on price variable. We understood that some of the properties were highly priced, and if we include those properties in our modeling data sets, they may be giving us some skewed results. Keeping in mind that we should not drop too much of the data, we limited our analysis to all the properties which were under $500. And by applying this filter, we dropped only 3% of the data, which was not that much. So the model was only built to predict the prices for properties under $500. So once the data set was prepared, we did a detailed exploratory data analysis, and we learned that some of the neighborhoods like Brooklyn and Manhattan were the top two neighborhoods with highest listings. Manhattan had the highest prices compared to other neighborhoods. Price fluctuations could be observed over 12 months for these listed properties. And also we learned that host attributes have no influence on price. During this exploratory data analysis, we learned that not all the properties will have a customer review. And the reason for that is, if a property has been listed quite new on the platform, so that property may not have any historical customer reviews. And we learned that about 20 to 25% of the properties each month had that scenario. So we did not want to drop those rows or impute them with some value, because these are new properties and we wanted them to treat them fairly and similarly, against different new properties that are coming onto the platform every month. So we will discuss about how we dealt with that issue in a minute. We also analyzed the impact of COVID-19 on Airbnb during our exploratory data analysis. While looking at the impact of COVID on Airbnb, we learned that since Jan 20, there has been a steady decline in number of active listings on the Airbnb platform for New York. And this was seen because there were many travel restrictions internationally and locally because of the lockdowns and safety protocols that were put in place because of COVID-19. When the market started opening up again, the host also started adding details in the property description that they are following some COVID safe protocols. So there were some very specific words that they started adding into the description of the property when they were listing it on Airbnb platform, and those were like COVID safe protocols, sanitizations or sanitizers available in the property. So those were the kind of common words that were available in the property description, and we can see that trend going up and up. So which means that more hosts are now trying to lure customers by telling them that the properties are for as per the COVID safe guidelines. As we didn't have access to the booking data, so we used the proxy, which is the number of reviews. So we wanted to understand if the bookings are also going down. So we can see that first of all, the non-English reviews have seen a drastic reduction because of international travel bans. There were no people, these properties were not getting enough international travelers. And also the number of reviews have gone down, which was a clear indication that if less number of people are staying in the property, then obviously they are giving lesser, there are lesser reviews as well. So this whole analysis helped us understand that not only there were less number of listings, there were less number of bookings as well, and also there was a change in the way Airbnb hosts were now operating, and by following more and more of COVID safe guidelines. So just before starting with any modeling, we wanted to set up the model, and during our exploratory data analysis we learned that not all properties have the customer reviews. So we thought of doing a dual model approach. So we built one model for existing properties which will contain all the features from the property dataset and also features from the customer reviews dataset, including the sentiment scores. And there would be another model that we'll create for new properties, and this will only be limited to the features for a property only. It won't have any features in relation to customer reviews. This setup enabled us to treat new properties fairly, and also we divided the datasets into test and control in the ratio of 70 and 30. 70% being under training dataset and 30% under control dataset or test dataset. As we knew that our dataset had about 750 observations or 750 columns, so we wanted to reduce these number of columns and apply any dimension. We applied dimensionality reduction techniques on it. First of all, we tried to condense all these amenities column into one which had similar meaning, like internet variable or Wi-Fi variable. We combined them as internet, and some features were like TV, OLED, 32-inch TV. We tried to combine them together under TV. So based on the business knowledge and also based on basic intuitiveness, we tried to condense some of those variables. After condensing them, we applied principal component analysis, and for both the models we got about 80 components. So from 750 we came down to about 80 variables that we would put in the models. The algorithms that we used for the modeling was, first was linear regression. So that was our baseline model. Then we applied the tree based techniques, random forest, and also the boosting algorithms XGBoost. And further we used advanced techniques like deep neural networks, where the activation function was linear, and we did lots of parameter tuning using dropout rates, batch normalization, learning rate, and callbacks. These were the results that came out after running those models. In both the setups for new properties and existing properties, deep neural network gave us the best results, where in the new properties modeling we got the R-square of 0.86 on the test dataset, and in the case of existing properties model our R-square was 0.81. We also wanted to check that if these results are better than the previous studies, so we picked up the two researches that were done on New York dataset, and we tried to check if their R-score was better than us or not. So in one of the studies which was done in 2019 on New York Airbnb data, support vector regression was their best performing algorithm with R-square of 0.77 on the 0.69 on the test dataset, whereas in the other study, in one more study, the XGBoost was the best performing algorithm with 0.61 as their R-square. We learned that the model that we prepared and the architecture of deep neural network that we used, it gave us better results than those studies, and the reason was that we used more data, did better feature engineering, applied dimensionality reduction approaches, and also deep neural network architectures were used. So I think this led us to get some better results. We also built this prototype. So in the prototype was built using HTML that uses Flask API web framework and executes the deep neural network model. This is the front page of the uh, prototype, where if you are an existing user, you would enter your property ID, and once you enter the property ID, you will be seeing this next page where most of the details will be pre-filled, because you are an existing user. So the prototype will, or the tool will pick up the information from the database, and some information can be adjusted if you want to change some offerings. And if you are and all the customer reviews will be populated, which are coming from the database again. If you are a new user, then all of this setup will be blank for you, because now you are a new property, you have to add all these details, but the customer reviews section would not be there for you. So once all these details are entered, the person has to click submit. But in the back end, because this is running on our local server, so this is how we would be executing it. And once the host will click submit, the recommended price will be shown on the screen. So this is how the prototype will also work, and this will enable and give the host the power to deploy these complex algorithms, and they don't even have to worry about the mathematics behind it. They can simply use this front end simple tool and get the recommendations of the price. Through our research, the conclusion that was drawn was we were able to build a robust price prediction model that where we managed to achieve better results. All the gaps that were identified during the literature review were completely addressed. COVID-19 surely impacted the Airbnb business and its operational model, and also choosing a different modeling approach and deep neural network architectures helped us achieve better results. Through this study, the contribution that we made to the field of Airbnb price prediction is that we explored the conversion of non-English reviews. So this was a new thing that we tried, and it wasn't tried earlier in any of the researches that we gone through. Deeper neural network architectures also helped us achieve some better results, and also the way we set up our model into one for new properties and one for existing properties, I think they helped us treat those properties fairly and enabled us to get some better results. So all these three approaches we observed were not tried earlier, and because of this we managed to get better results on the test data set. Some of the future recommendations that we think other new researchers can look at is they can further expand the data to other geographies, because right now the model that we built is still limited to one geography, which is New York. So I think expanding this to other geographies and building a generalized model will be good for a wider application. Also, exploring the other free text field like name of the property, description of the property, and details about neighborhood, they are all free text field. So those fields can also be utilized, and latest NLP technologies like BERT or transformers can be utilized there to get some better results. And also better neural network architecture and changes to activation function and better parameter tuning can help us enhance the results and performance of the model in a better way. So this brings me to the closure of my final thesis presentation. I would like to thank my supervisor Ankit Bhatia who has helped me a lot in guiding me through this thesis. Thank you all for your time.